Hi guys, welcome to Chem or Chem. In this video, we are going to see Shiina esterification. If you are new to this channel, please subscribe. Now we'll see the Shiina esterification. In Shiina esterification, there are two reaction conditions are known in literature. First one is based on Lewis acid promoted Shiina esterification, and second one is nucleophilic base promoted Shiina esterification. However, in this video, we are going to see nucleophilic base promoted Shiina esterification. So according to in this reaction, carboxylic acid and alcohols reacted in the presence of acid anhydride and triethylamine and DMAP that provides corresponding ester compound. So now we'll see what are the reagents are needed to conduct this reaction. And first one is MNBA, that's called 2-methyl-6-nitrobenzoic anhydride. So this reagents necessary in order to conduct this reaction. Even this reagent is called Shiina reagent. Next we need DMAP. Here DMAP acts as a nucleophilic base. Instead of DMAP, sometimes people use DMAPO also. Apart from this, we need one tertiary organic base. In most of the time, people use triethylamine. Even diisopropylethylamine also can be useful for this reaction. Next, we move on the mechanism. So initially, carboxylic acid reacted with triethylamine. Here you see triethylamine nitrogen has lone pair of electron, which takes the proton from carboxylic acid, resulting that this OH bond breaks down. These electrons moves towards to the carbonyl carbon, then followed by carbonyl oxygen bonded electron moves towards to the oxygen, since oxygen has more electronegative element, which results that provide corresponding carboxylate ion as well as protonated triethylamine. This carboxylate ion quickly react with MNBA. Here you see MNBA has two carbonyl carbon, which react one of the carbonyl carbon. You see how that reacts. So here oxygen negative charge comes in, then carbon oxygen double bonded electron attacks one of the carbonyl carbon, which leads to generate this tetrahedral intermediate, which then readily collapse to kick off 2-methyl-6-nitro-benzene carboxylate ion as well as one mixed anhydride. Now this mixed anhydride react with nucleophilic DMAP base. So here you see DMAP selectively react with only one of the carbonyl rather than another carbonyl, because this carbonyl heavily shielded with methyl as well as nitro group. Because of that steric hindrance, our DMAP selectively react with this carbonyl carbon, so that leads to provide corresponding tetrahedral intermediate. Now this tetrahedral intermediate also quickly collapse, which leads to generate one more 2-methyl-6-nitro-carboxylate ion as well as acylated DMAP. So this acylated DMAP has resonance stabilized. Here you see how it stabilized. This nitrogen lone pair of electrons goes in, then followed by this electron shifted here, this electron shifted towards to the nitrogen, since nitrogen has positive charge. So resulting that we will get this type of resonance structure. In this way, this acylated DMAP has stabilized by resonance. Then after that alcohol, so the alcohol oxygen has two lone pair of electron. One of the lone pair of electron attacks the acylated DMAP carbonyl carbon. So resulting that generate corresponding tetrahedral intermediate, which then collapsed, that kick off the DMAP as a byproduct and followed by this intermediate. Then DMAP readily takes the proton from this intermediate, which provides corresponding ester as well as protonated DMAP. So in this reaction, DMAP acts as a acyl transfer reagent as well as MNBA act as a degateating agent in this Shiina esterification. Here I would like to remind you about Yamaguchi esterification. So Yamaguchi esterification closely related to Shina esterification. In Yamaguchi esterification, we need acid chloride in order to generate the acylated DMAP. So here in Shina esterification, they use acid anhydride. So this is the one simple difference between the Yamaguchi and Shina esterification reaction. So next we move on some of the important examples based on the Shina esterification. In general, Shina esterification mostly useful for preparation of macrocyclic lactone. Here you see one of the example. So in this molecule, first position has carboxylic acid group and seventh position has hydroxy group. When you subject under Shina esterification condition, that provides corresponding 8-membered lactone, macrocyclic lactone ring. So not only 8-member ring, even 4-membered strained lactone ring can be prepared by using Shina esterification condition. Here you see that molecule, second position has hydroxy group, fourth position has carboxylic acid group. When we subject under this condition, that generates 4-membered cyclic lactones. So not only 4-membered ring, even 29-membered also can be prepared by using Shina esterification condition. Now you look this molecule, first position has carboxylic acid group, while in the 28th and 24th position has 2 alcohol group. However, the 28th position has a primary alcohol group selectively react under this condition that generate corresponding macrocyclic lactone. So not only intramolecular reaction, even intermolecular reaction also possible when we use Shina esterification reaction condition. Here you take this molecule has hydroxy group and this molecule has carboxylic acid. When we subject under this condition, that generate corresponding ester molecule. So this is another example for preparation of macrocyclic lactone by utilizing Shina esterification condition. Here you should note in all these reaction conditions they used DMAP, but here they use DMAPO. So I already said DMAPO also useful for preparation of this type of ester molecule. So just like DMAPO also plays the same role. So when DMAPO react with mixed anhydride, that generates corresponding acylated DMAPO. So again, this DMAPO, acylated DMAPO also resonance stabilized, which then react with alcohol that generates the corresponding cyclic lactones. So when you get your free time, you just try to work it out, these problems based on the Shina esterification. In our channel, we discussed a series of esterification, macrolactonization reactions. If you miss this series of reaction, you just log on our channel. You can find these videos.